Records, introduced in Java 14 as preview feature and finalized in Java 16, are special kind of class designed to hold immutable data. They significantly reduce boilerplate code by automatically generating constructors, equals, hash code, and toString methods. Imagine we need to create a student class with just name and age. Let's create it with the plain old Java class. Let's create a constructor so that we can create an object of student class and set the values into the fields. Let's also add getter methods to access the name and age properties of student. Let's also override the equals and hash code method and the toString method. So as you can see, we have created a student class with name and age field in it. And we have around 35 lines of code. Let's try the same example with a record. So as you can see, we have created a record. Let's look at its syntax and usage. For creating a record, you will have to use a record keyword instead of the class keyword. Presiding that, you can give the name of the record and you can also mention the components which are required in the round bracket. In this case, we have the string name and integer age. Let's create object of our student class and the student record which we have created. In this example, I have created two objects of student class and student record respectively. Let's print out its value. As you can see, the student class as well as the student record objects are printed and they are able to store the values in it. Now let's try accessing the data in it. Let's first try with the student class. In order to get the student name, you can directly call the method getName in it. And in case of a record, you will have to directly access it using the component name which you have given. In my case, it is just name. So as you can see, for accessing the value in an object of a student class, we'll have to use the getName method. And in case of a record, we'll have to directly access it using the component name which is given. Let's run it. As you can see, we are able to print the values. There are few advanced features in records. Let's try it out. Records allow you to create custom methods in it. Let's create a method in student record for checking a student is eligible for voting or not. As you can see in the record, we have created a custom method for checking whether a student is eligible for voting or not. All fields in the record are final and can be set through a constructor. But here we cannot see any constructor. By default, the compiler creates constructor for you. It's also called as Canonical Constructor. This constructor takes the components of your record as argument and copies their value to fields of the record class. You can also add validation in constructor. Let's try it out with an example. Here we have added a validation to check whether the given age of the student is non-negative. As we have added the validation, let's store the values into the field. Now let's look what is a compact constructor. Unlike the canonical constructor, we don't have to set the components manually. A compact constructor will be always called by a canonical constructor by default. We also don't have to pass the argument in it as we were doing it in the canonical constructor. Let's try it out. For that, I'll be commenting the previous code. So as you can see, we have just added the validation in it, and setting the value is taken care by the record itself. A big difference between record and classes are records are strongly immutable by default. You cannot change a record after it is constructed, even using reflection. You can take this to next level by making it deeply immutable. Let's create a record grade with marks and subject in it. Let's add the grade into the student record. Let's uncomment the canonical constructor which we have, and let's add the student grades into it. Instead of directly storing it into the object, here we can use the unmodifiable list given by the collection. So this will guarantee us nothing in this record can be modified once created. Let's add a custom method through which we can calculate the student percentage based on the grades we have. As you can see, we have created a custom method which can calculate student percentage based on the grades given for the student. Let's look at few use cases where you can use the records. Records can be mainly used as a data transfer object. It can be also used as model classes, or you can also use them as a read-only data object. There are few limitations with records. Fields in records are final and cannot be modified. Records cannot extend other classes, but they can implement interfaces. Avoid using records when mutable behavior is required in your object. And you can also avoid using records when you have a complex logic. You cannot create an instance field in record. Let's try it out. So as you can see, it's throwing an error. Let's remove it. Let's compare the traditional Java class with records. For declaration of a traditional class, you will require a class keyword. And in case of a record, you will require a record keyword. Talking about the boilerplate code. In a traditional class, you will have to implement the constructor, getters, equals, hash code, and toString method. In case of a Java record, no need to explicitly define constructors, getters, equals, or hash code. Let's talk about mutability. Traditional Java classes are mutable by default. Java records, on the other hand, are immutable in nature. All fields in it are final. Let's talk about inheritance. Traditional classes support inheritance. Java records cannot extend to other class, but they can implement interfaces. The best use case for a traditional class will be when you want a mutable object with a complex logic in it. And in case of a record, it's immutable object which can be used as a read-only data. Java records simplify data classes with immutable fields, enhance code readability, and reduces boilerplate code. Use records where immutability and simplicity are essential.